Here is one of the spiral galaxies close to us, with an active nucleus. More precisely, a Seyfert galaxy type 2. It has long been established that the jets emanating from its core move in the disk and interact with its matter. This interaction produces certain types of chemicals, and these chemicals are markers of such interactions. And recent high-resolution images of this galaxy have shown that these markers of high-speed gas collisions extend from the galaxy's core along the bar and spiral arms. In other words, these images indicate high-speed gas movement along the bar and spiral arms. This supports the idea that jets of gas flowing from the galactic core create a spiral structure in the disk of spiral galaxies. And this movement of gas also affects stars. The star can either increase its mass by receiving a portion of fresh gas and begin to shine like a young star, or it can explode. And this explains why the brightest, youngest, and most massive stars are located in spiral arms. Moreover, scientists still do not know how such massive stars are formed. This also explains why most Type II supernova explosions occur in spiral arms. In other words, jets of gas moving through the disk create a spiral pattern of young bright stars and supernova explosions. This also explains why in some galaxies a spiral pattern of gas is present far beyond the visible disk. This movement of gas also resolves the G-dwarf problem and many other problems and mysteries of astrophysics. You can learn more about this in video number 10. And let me remind you that there is a very important unsolved mystery in astrophysics, which sounds like this. Why don't spiral galaxies have jets like quasars? Such jets are found in elliptical and lenticular galaxies, but spiral galaxies don't have them. And the answer is simple. There are jets in a spiral galaxy, but they are directed into the disk. In other words, the core of a spiral galaxy is a small quasar, with relatively weak jets directed into the disk. It may seem that this galaxy is just an exception, and this doesn't mean at all that everything is the same in other spiral galaxies. And the problem is that the gas and dust in the disk of the galaxy quite well masks the processes occurring deep in the disk. But now jets in the disks of spiral galaxies have begun to detect it more and more often thanks to the more modern equipment. More details in video number 10.